Hey everyone. So in today's lesson, we're going to be discussing a little bit more of what we were talking about in the last video, which was multiplication and division involving decimals. So we talked a little bit about division last time. We spent a lot of the time focusing on multiplication and specifically long multiplication. And in this video we're going to focus more on division, and then we'll go back to multiplication towards the end so that we can talk about using lattice multiplication to solve multiplication problems involving decimals. So up until this point we've just talked about long multiplication and a little bit with long division as well. So in this video we're going to go over a couple more questions for division and some different techniques you can use when you're solving those problems, and then we'll switch back to multiplication for the end of this video. So let's start with, let me pull out the first problem. So I believe we only did one in the last video for division, so we'll start with the second problem that I have right here. So the problem at hand is 124.3 divided by 3. Alright, so I've made this small right now because I'm going to need to use some space over here to actually work through this problem. So it's going to be 124.3 divided by 3. So we're still going to set it up as we normally would. So we have 124.3 as our dividend, so that's going to go underneath this. And then we have a 3 on the outside. So on your test, I'm going to hopefully not go back on this, but on your test for this unit, I'm going to try and keep it so that the divisor, the second number, is always a whole number, so you never have to worry about doing anything extra with this. But the first problem we're going to do, this dividend, this 124.3, obviously has a decimal, but the divisor does not. In a couple of problems we'll do after this, I'm going to show you what you can do if your divisor has a decimal as well. So I'm not going to probably test you on that one, but it'll be good for you to see it once or twice before we get to the test for this unit, which will be next week as of the time of recording. So our first step is we're actually going to go through the problem just like when we did long multiplication. We're going to go through the problem ignoring this decimal point right here. So we're going to go through the whole thing as though there's no decimal point there at all, and then we're going to throw in the decimal point when it becomes relevant. So you'll see what I mean as we go through it. So we already did one example of this last time, I believe, and I hope we did that one. Yes, I think we did that one, yes. So what we'll do here is we start the same way that we always do. So we ask ourselves, how many times does 3 go into 1? And obviously 3 doesn't go into 1, so we move on and we consider this 12 here. We consider the next digit. So we ask ourselves, how many times does 3 go into 12? And so 3 goes into 12 4 times, right? So we put the 4 up top. And remember, that 4 needs to go above this 2, above the last digit that you're asking yourself about, right? So if we were asking ourselves, how many times does 3 go into 1? The number that we would put there, which if you wanted you could put a 0 here, would go above the 1, since that's the only digit we're considering. But because we're asking ourselves about the 12, and we're taking into account this 2 when we ask ourselves that, then when we get that answer of 4, it needs to line up with this 2. And you'll see why that's important a little bit later on as we go through this. So 3 goes into 12 4 times, and we know that 3 times 4 is equal to 12, so that'll slot in right here, and we subtract that. So we get 12 minus 12 is going to be 0, and we pull down the next digit, which in this case is a 4. So now we pull down this 4, and we ask ourselves how many times does 3 go into 4, which is, so far it's exactly the same as what we did before. So 3 goes into 4 just once, so we put a 1 up top, above that 4, directly above that 4. And then we know 3 times 1, that 1 up there, is equal to 3, so that's going to slot in right here, and we're going to subtract. And we get 4 minus 3 is 1. Right, so I'm going to actually have to make this a little bit smaller just because we're going to have a whole bunch of extra steps. But yeah, so we get minus 3, which leaves us with just 1. Now we take this next digit and we're going to pull that down and make this a 13. Notice, however, that I have ignored the decimal point. When I bring this down here, I bring this 3 down, but I don't bring the decimal point down because that's going to confuse us. If I brought that down here, I'm asking myself how many times 3 goes into 1.3, and the whole thing that we're trying to avoid in this is having to deal with working with decimals in a long division problem. The way we actually work through it, the decimal point doesn't interfere with anything while we're working through the problem. So we treat this as how many times does 3 go into 13. So we pretend that there's no decimal point in the middle, and so you're going to get that 3 goes into 13 4 times, right? So we're going to put a 4 up above that 3 right there. We know, once again, 3 times 4, 3 times 4 is equal to 12. So that's going to slot in right here. 13 minus 12, we subtract, and we get a 1. Right, so after this, we know that 124.3 is exactly the same as 124.30, right? And that's also the same as 124.300. So if I keep adding extra zeros to the end of my dividend, that's not going to change the number that I'm dealing with. So I have this 1 down here, and I'm going to put a 0 at the end of my dividend. So I've made this, instead of 124.3, I've made it 124.30. So I haven't changed the value of this dividend, but I've just added this extra 0 as a digit that I can pull down beside this 1 down here. And we make this a 10. So now we go through this one more time and we ask ourselves, how many times does 3 go into 10? And we get that 3 goes into 10 3 times. So we're going to put a 3 up here. And 3 times 3 is going to give us 9, so 9 will slot in over here, 10 minus 9, which leaves us with a 1, once again, right? But we know that I could add in another 0 here, right? I could turn this from 124.30 to 124.300, and I put that extra 0 in, I pull it down, and we have a 10, once again on the bottom. Now if we go through it again, how many times does 3 go into 10? It goes into 10 3 times. We put the 3 up top. 3 times 3 is 9. We put that here. We subtract. 10 minus 9 leaves us with 1. You might see that this pattern down here is starting to repeat a little bit, right? So if I bring this closer, you can see here now, hopefully, that so we had this 10, right? And then we asked ourselves, how many times does 3 go into 10? And we got that it goes in 3 times, so we put a 3 up top. And so we did 3 times 3 is 9, put that over here, and we subtracted, and that left us with a 1. Then we brought down a 0, right? We added on an extra 0 upstairs, brought that down, and we had a 10 again. So we asked ourselves, how many times does 3 go into 10? It goes 3 times, we put a 3 upstairs, we got a 9 down here, and we subtracted, and it left us with a 1. If I want, I could put another 0 here, and bring that down, and that's going to give us 10 again, down here. But we know that this is just going to repeat forever and ever, right? Every time I do this, 3 is going to go into 10 3 times, there's going to be a 3 up there, I'm going to have a 9 come down here, do the subtraction, and I get a 1. Then I bring down a 0, and I'm going to have a 10. And I ask myself the same question over and over and over again. So once you notice that pattern, you might have to go through it 3 or 4 times to notice the pattern, but you can see here that suddenly we've got 10 minus 9 is 1. Bring down a 0, 10 minus 9 is 1. Bring down a 0, 10 minus, and it's going to just keep going on forever. So we can have confidence in saying that up here, that we have this 4, 3, 3, and that those 3's are just going to continue forever. So the only thing we're missing now is that this decimal point from our dividend needs to line up with our quotient, and that's where lining up the digits becomes really important. We line up this 4 over here with that 2, we line up this 1 with that 4, and we have to line up a decimal point here with the decimal point from our dividend, and then we can do 4, 3, 3, 3, 3, 3 forever, right? So we can have a whole bunch of 3's going on forever. And so that would give us our final answer for this question. And the way that you would express a final answer of this type, the type that repeats over and over again, is, so we got our answer was, so we got 124.3 divided by 3 is equal to 41.4, and then we have an infinite string of 3's, right? This is never going to end. We're just going to have 3's until the end of time. So instead of writing a whole bunch of 3's here, we write 1 3, and then we just put a bar over it like that. And so that is an indication that this is going to be 41.4 and then an infinite string of 3's. So if you were going through one of these problems and you were getting like digits that are repeating at the end, so it could be 3's, could be 6's, sometimes it'll be sequences of digits that repeat, that you might have like a 576 that just goes 576, 576, 576, then you would write those digits and then just put a bar over all of them, and then that would be an indication that that series of digits is just going to repeat forever and ever, basically to the end of time. So it saves you a lot of writing with your final answer, and it might help you out with, oh well, you know, how many decimals should I write down? Should I just write the 4? Should I write 4 3? Should I write like a whole bunch of 3's so that you get the idea? You can just put 4 3 and then that bar over top to indicate that that it repeats forever. All right, so that's the way this type of problem works, and we're going to do another one, or actually we're going to do 2 more for division, and then we'll switch back to multiplication, where we focus on lattice multiplication for a change. So with this next division problem, I'm going to take this one slow to begin with as well, because this one is slightly different from the ones we've done so far. And then the one after that we'll pick up the pace a little bit, just so that we make sure we get time to at least touch on the lattice multiplication today in this lesson. So the next problem we're going to do is we are going to start with 2.3, and we're going to divide that by 0.3. So now our divisor also has a decimal point, so we're going to have to be a little bit careful. So the way this would normally be set up is you would have your 2.3 here, and then you have that thing, and then you have your 0.3 on the outside like that. However, we don't want to be working with a decimal number in our divisor. Ideally, we want this thing out here to be a whole number, and that'll make things a lot easier for us once we can get that. So if you look at this, basically we could rewrite this as a fraction. We could write this as 2.3 divided by 0.3, like that. Right? That's the same thing. This line here, when you write it as a fraction, that implies division. So we've got 2.3 divided by 0.3. But I don't want this to be 0.3. I want to make this a whole number. And so the easiest way to do that would be to take this 0.3 and multiply it by 10. And if I multiply it by 10, then that's going to give me 0.3 times 10, which is just going to become a 3, right? So remember, if you've got 0.3 like this, and you're multiplying by 10, you just take this decimal point and you just chuck it one spot over to the right. If it was times 100, then you would chuck it an extra spot over to the right, and you'd fill that empty gap with a 0, and so it would become 30 if you were multiplying by 100. But since we're only multiplying by 10, we just move the decimal spot over by 1, and it becomes 3. So we get a 3 on the bottom. But we're not allowed to just change one of these numbers, because then that changes the whole question. Right now, instead of doing 2.3 divided by 0.3, we're doing 2.3 divided by 3, apparently, which is changing the question. So what you have to do is, to make up for this multiplication by 10 that you're doing down here to the 0.3, you also have to do it up here to the 2.3. Right? So if we've got 2.3 also times 10, then that's the same thing. We've got 2.3, and then when you multiply by 10, you take this decimal point and you just chuck it one spot over to the right, and that makes it 23, right? It would be 23 or 23.0 or whatever, right? So you end up with 23.3 instead, and that's exactly the same number as 2.3 divided by 0.3. So if you did the division for this and the division for this, and you solve it with long division, you'll actually get the same answer for this one and for that one, as long as you've multiplied them both by the same thing, right? So we've multiplied the top by 10, we've multiplied the bottom by 10, and so this problem is easier for us to deal with, and we've actually turned it back into a problem that doesn't involve decimals at all. So we've taken this 2.3 divided by 0.3 and we've made it 23 divided by 3. And so that's the problem that we're now going to work with. So I'm going to erase this stuff in the middle just because I need some room to actually write the problem. But what we're going to do that's slightly different this time is we're going to, so we've got 23 divided by 3. We're going to still solve the problem, and if there's a remainder, we're going to use decimals instead of just writing R, like capital R, and then a 1 or a 2 or whatever. So we've got 23 divided by 3, and we're going to solve this the way we normally would, but if we end up with a remainder, then we're going to solve it using decimals instead of using just the remainder. So the first question we ask ourselves is, how many times does 3 go into 2? Obviously it doesn't, so we ask ourselves, how many times does 3 go into 23? And so 3 goes into 23 7 times, so we'll put a 7 up top. 3 times 7 is equal to 21, so that'll slot in right here. And then we're going to subtract. 23 minus 21 is going to leave us with 2. Right now, so we started with a 23 here, but 23 is the same as 23.0, right? And that's the same as 23.00. And that's the same as 23.000. So it's the same thing, that I can turn this, even though we don't have decimals in this problem. Right now, I have a remainder of 2 because I've run out of digits, but I don't want to solve this with remainders. I want to solve this with decimals. So what I do is I turn this 23 into 23.0, and then I take that 0 and I pull it down and I make this a 20 down here. Now I'm going to ask myself, remember, we're going to ignore the decimal point. We're not going to bring the decimal point down and make this a 2 again. So we're going to ask ourselves, we're going to treat this as a 20 and ask ourselves, how many times does 3 go into 20? And 3 goes into 20 6 times, so we'll put a 6 up there above the 0. And then we do 3 times 6 is equal to 18, so that 18 will slot in right here, and we subtract. 20 minus 18 will leave us with 2. So at this point, once again, we've still got that remainder of 2, and we don't want that, so we tack on an extra 0 into our dividend, with 23.00, that's still 23, and then we pull down that 0, and we make this a 20 down here instead. So we've got a 20 again. We ask ourselves one more time, how many times does 3 go into 20? It goes into 20 6 times, so we put that up there. 6 times 3 is going to be 18, so we put another 18 here, and we subtract, and we're left with 2. Now you might be seeing the pattern. Once again, this is the same pattern that we were getting before, is that if I put another 0 here and I pull that down, my dividend is still 23, but I'm going to get another 20 down here. 3 goes into 20 6 times, I'm going to get a 6 up there. 3 times 6 is 18. I'm going to subtract, and I'm going to get a 2. And if I put another 0 and put that down there, I'm going to get another 20, another 6 up there, another 18, and another 2. And this is going to go on forever and ever and ever. So if you're seeing that you're getting the same remainder every time, so we were left with a 2, we pulled down a 0, we did the division and the subtraction, and we were left with a 2, and we brought down a 0, and we did the process all over again, we were left with a 2. That's an indication that it's going to repeat forever and ever. So the last thing we have to do is we line up this decimal here up there in our quotient. And if you feel like you're going to forget this, you don't have to wait until the end to do that. When you write that 7 and you do this first bit, and then you're ready to go up and write that 6, if you remember right then to line up that decimal, go ahead and do it at the beginning. If you want to do it at the end, that's fine too. Just make sure you don't give an answer that's like 7,666 for the number of times 3 goes into 23. So that's the only risk with leaving the decimal bit for the end, is that there's a chance you'll just forget it entirely and submit an answer of like 766 instead of 7.66, right? Depending on how far you go with those decimals. So for this problem, we can see that our answer is going to be 7, and then a decimal point, and then just this endless string of 6s. So when we write our final answer, we're going to write it, we're going to save ourselves some writing, and we're going to say that 23 divided by 3 is equal to 7 point, and then we put a 6 and a line over top of it. So the only thing that's not maybe the most correct about what we've done so far with writing this solution the way it is that the question didn't ask for 23 divided by 3. The question asked for 2.3 divided by 0.3. So ideally, if you're going to put a final statement in your answer, you should put it back into the form of the original question. Even if you, in step number 1, changed the question's appearance. You didn't actually change the answer of the question. This answer of 7.66666 satisfies the original question, but in step 1 we changed the appearance of the question to suit our needs a little bit better. But if you're going to make this final statement and you're not just going to like circle your quotient or something, then it is good to try and remind yourself, oh right, the original question had some decimal points in it, so I should put those back in there. Alright, so hopefully that's making sense. So that's the second example today of long division. We're going to do one more. I'm going to try and pick up the pace a little bit just so that you can see an example for lattice multiplication in this video as well. And then I'm going to make one more video after this on practice problems before your test, and then there will hopefully be after that there will be for sure a video for your test review. I'm going to try and keep it short so that you guys can watch it in time if you're falling behind by video or by like a half a video or something, and also you can refer back to it over the weekend, and then it'll give you guys more time to study. So I'll just briefly go over all the topics for your test in a future video. But for now, we're going to do one more long division problem. So here we've got 15.26 divided by 0.4. So this problem isn't overly different from the last one. We don't want a divisor of 0.4. We want this divisor to be a whole number. So what we do is we're going to take this divisor and we're going to multiply it by 10, and that's going to give us a 4. Right? 0.4, you multiply it by 10, you're going to just chuck the decimal point over to right there. And so then you end up with a 4, right? So if I leave it like this, we get 0.4 times 10 is going to give us a 4 down here, right? And then if we're multiplying this side by 10, this divisor, then we should also be multiplying our dividend by 10, because otherwise we're changing the question. So we take this thing and we multiply that by 10, and that's going to give us 152.6. We take that decimal point and we just chuck it one spot over to the other side of that 2. So this is our new dividend, and that 4 is our new divisor. And so this is now the problem that we're working with. So the only thing that's different between this problem and the last problem is that our divisor is now a whole number, but our dividend is still a decimal number, right? It still has this 0.6 on the end of it. So let's go through it and let's see what this gives us. So we've got 152.6, and then we're going to divide that by 4. Alright, so we ask ourselves the same first question as always. How many times does 4 go into 1? It doesn't, so then we tack on that 5 and we ask ourselves how many times does 4 go into 15? And it goes into 15 3 times. 4 times 3 is equal to 12, so that 12 is going to slot in right here, and we're going to subtract. 15 minus 12 is going to leave us with 3. So we bring down the next digit, only the next digit, and that's going to be a 2. Now we ask ourselves, how many times does 4 go into 32? And we get that 4 goes into 32 8 times if you do the math. 4 times 8 is going to equal 32 exactly, so that's going to slot in right here. And we do 32 minus 32, obviously leaves us with 0. Then we take the next digit, that's 6, and we're going to pull that down. Remember, ignore bringing down this decimal point to here. You don't want to do that because it'll confuse you when you're asking yourself this next question. So just bring down the 6, and you're going to ask yourself, how many times does 4 go into 6? Now 4 goes into 6 just once, so we'll put that 1 up there. But at this point you could, if you notice, oh, well, this 1 lines up with that 6, which is behind the decimal, so I might as well right now just chuck the decimal point in there so that I don't forget to do it later. Alright, the downside to this, instead of doing it at the end, is that it sort of breaks your train of thought. You put that 1 up there, then you put the decimal point, and then you got to sort of backtrack and figure out, okay, what do I have to do after I put that 1 there? So let's remind ourselves what we did. We said 4 goes into 6 once, we put that there, then we remember to put the decimal spot in, and then we do 4 times 1, right, the 1 that we have up there is equal to 4, so that's going to slot in right here. 6 minus 4 is going to leave us with 2. Alright, now we've run out of digits up here in our dividend, but we have this 2 down here, so we're not happy with that, right? We don't want a remainder. So we turn this 152.6 into 152.60. So we haven't changed the dividend at all, we've just added a 0 so that it gives us something new to pull down here. And with this number, it's actually going to work out quite nicely, because then you ask yourself, once you've brought that 0 down here, you turn the 2 into a 20, and you ask yourself, how many times does 4 go into 20? 4 goes into 20 5 times, so we put a 5 up there. 4 times 5 is equal to 20 exactly. So we put the 20 in here, and we subtract. 20 minus 20 is 0. So now that you've got this 0 here, you don't need to keep pulling zeros down. Once you have a 0 down here as a remainder, that's what you want. That's what makes you happy. So having a 0 down here is the end goal if you're trying to get a quotient that has a decimal and you're trying not to have a remainder. So you can stop once you get this 0 down here. So then we can say that our answer is complete. We've finished the problem, and our answer is going to be that result right there. So we get that 152.6 divided by 4, which is the same thing as what we started with. 15.26 divided by 0.4 is equal to 38.15. So that's our answer right there. 38.15 is the answer to this problem. So you're allowed to fiddle with the problem a little bit if it makes doing the math a little bit easier. And this multiplying by 10 to get a whole number for a divisor is a good example of a way in which you can do that. So I'm just going to wrap up this video quickly with at least one, but possibly two examples, two if it goes quickly, of lattice multiplication involving decimals as well. So I'm going to get rid of this problem. It'll also give us a chance to revisit lattice multiplication one more time before your test review. So back to multiplication involving decimals. And so we're going to do the problem 41.7 times 3.8. So if you remember, when you set this up as a lattice, you're going to have the 4, the 1, and the 7 here, and you're going to have the 3 and the 8 down the side of your boxes, on the side of your lattice, right? So I'm going to put these boxes in here, right? And then we have these lines going like this, and then we have this going across. Those boxes are not an equal size, but we'll make do. Alright, so we go through this problem the way we did before, and we can plonk these decimals in right here. Let's put that decimal there, right on top of that line for 41.7, and for 3.8 we'll plonk that decimal in line with this black line in the middle. Alright, so now we're not gonna pay those decimals any attention for the time being, and we'll just go through the multiplication. So we do the multiplication. 7 times 3 is 21, 7 times 8 is 56, 1 times 3 is 3, 1 times 8 is 8, 4 times 3 is 12, and 4 times 8 is 32. Hopefully that wasn't too quick. And now we can go through and do the addition, right? This isn't two particularly large numbers, so hopefully this is making sense so far. So the 6 sits by itself down here. 8 plus 5 is 13, plus 1 is 14, carry the 1. 2 plus 3 is 5, plus 2 is 7, plus 1 is 8, so we get an 8 here. 3 plus 2 is 5, which will go there, and then this 1 sits by itself. Now we have to remember about these decimals here. We have to remember what to do with them. So what you do is you take this decimal point and you're going to draw a line going down. You can sort of just darken the line that you had before, and you're just going to draw a line across from the other decimal. So if you remember, we lined them up over this line and next to that line. So you're just going to draw two lines closing in from there, right? So you're going to start at the two decimal points, and you're just going to draw a vertical line and a horizontal line until they meet. And so they're going to meet at one of these corners. So you see that? So this decimal point right here goes down there. This decimal point over here goes across, and they meet. So we start like this, and they come in and they meet right there. And then from there, they're just going to follow the diagonal that they're on. So they're going to meet at a corner, and there's going to be a diagonal that's going down towards the left. So they're just going to follow that diagonal down, and that's where you're going to plonk your decimal. So you're going to put a dot right there. And so you would get that your final answer in this case is 158.46. Alright, so without that decimal point, it would have been 15,846 if we didn't have any decimals here. But you can also check that if we did this with long multiplication, there's one digit after the decimal here, one digit after the decimal here. So in total, we have 2 digits after the decimal point. So we just make sure that we have 2 digits after the decimal point in our final answer over there. So we can do the whole problem without any decimals, and then just do that quick check at the end and put the decimal right there. Alright, so I'm going to do one more really quickly, just to wrap up this video. And then in the next video, it'll just be a whole bunch of practice problems, and then a test review for you guys. And then your test will be next week. So, let's start. So this last problem, is going to be 23.8 times 0.12. Now, when I'm making my boxes, I don't really need to deal with this zero in front. I could just worry about the 12 and put the decimal point right up at the top. So I'm only going to make this another 3 by 2 box like the last question. I'm going to have my box like this. I'm going to put that there. I'm going to put that there. I'm going to have this going down here. This going down here. This going down here. This one going down here, and then that one just because I like having an extra one over there. Alright, and then we're going to fill in our numbers. So we've got 2, 3, and 8 over there, and then down the side we have 1 and 2. So this was actually 23.8, so we're going to put a decimal point right here. And this is 0.12, so if you wanted to make this a 3 by 3, you could, if you wanted to put a third row and have a 0 in the first row, you could do that, but I don't feel like filling a row full of zeros, so I'm just going to put the decimal point right there, and I've made this effectively 0.12, like that, but I just don't need to include the 0 because it's out in front. So now we can quickly go through the multiplication and just finish this off. So we get 8 times 1 is 8, 8 times 2 is 16, 3 times 1 is 3, 3 times 2 is 6, 2 times 1 is 2, and 2 times 2 is 4. Then we go through, the 6 is sitting by itself, 8 plus 6 is 14, plus 1 is 15. Carry the 1. 4 plus 3 is 7, plus 1 is 8. We don't have to carry anything. This 2 plus 0 plus 0, that's going to just give us a 2, and then we've got a 0 there. Now from this decimal point, we could draw a line going straight down, but it's never going to actually meet the other decimal. If we just try to make these two decimal points meet each other, they're actually going to meet right here, right? This is going to go only down this far, and this one is going to come across, and they're going to intersect right up there, all the way up top. So that's where you've got to be careful if you're ignoring that 0 and you're putting your decimal point all the way up there, is you're going to have to be watchful of where they cross paths. But then from there, you just follow this diagonal going down, and it comes down here to between the 2 and the 8. So you would put your decimal point right there, and then you can get your final answer by just reading it off and making sure you have the decimal in the right spot. And you get a final answer of 2.856, which once again, using the method that we did with long multiplication, you can see that there's a total of 3 digits after the decimal point up in our two factors. So we've got the 8 here, the 1 there, and the 2 there. So altogether we have 3 digits that are after the decimal point there. And in our final answer we also have 3 digits after the decimal point there. So basically with multiplication and division is sometimes you need to do a little bit of manipulating of the problem, but otherwise in general you can do the problem kind of without worrying about the decimals at all, and then just throw them in at the very end into your final answer. So hopefully all of that made sense. I know this lesson was a little bit longer than I would have hoped for, so hopefully you guys are getting through these all right, and hopefully everything is making sense. There will be more practice problems and a test review coming your way in the near future, but until then, keep practicing this and enjoy yourselves. See you next time.